Hello students, good morning. So we are starting classification of elements and its periodic trend, right? Today our topic is anomalous behavior. Anomalous means that behavior of element which is different from other member of this element. Means in the same group, if a member is showing different behavior, then it is called anomalous behavior. For example, in case of first group, in case of first group, members are lithium, sodium, potassium, rubidium, cesium, francium. So lithium have different property than other members. Other members are very soft, like sodium is very soft. You can cut sodium with the help of a knife, but lithium is a hard material. So lithium shows different property than other member of this group. That is called anomalous behavior. So each and every group, first member of each and every group shows anomalous behavior, especially in S and P block element. So these are four points. In case of any group, first member of that group is very small in size, very small in size. There is a large difference of atomic size between first member and second member. So first member of any group is very small in size. Like fluorine is very small than chlorine, bromine, iodine. Lithium is very small than sodium, potassium. Electronegativity is very high. So one thing, if you remember, in previous lecture we have discussed about ionization enthalpy trend, electronegativity trend, and negative electron gain enthalpy trend. So in a group, these all properties are decreasing as we move from top to bottom. Or so we have a trend of this. We have started the trend of these all three properties. So electronegativity is very high, means first member of any element have very high electronegativity. Actually electronegativity depends on size. So as we move down the group, atomic radius will increase. But as we move in a period, electronegativity will what? Increases due to decrease in atomic radius. So first member of any element, any group have very high electronegativity. Similarly, very high ionization enthalpy, because if first member is very small in size, then we need a very large amount of energy to break its bond. So ionization, or to add electron, so ionization enthalpy is very high. As we move down the group, ionization enthalpy will decreases. And fourth is it has maximum 4 valence electron. So in for first member of any group, either it's 2s or 2p, or 2s and 2p also. So one maximum electron in case of S is 1, in case of P is 3. So maximum 3 plus 1, 4. So we have only 4 vacancies in orbitals. So maximum valency will be 4. Or you can also say that absence of d orbital. So your basic properties are due to very small size. First member of any group shows anomalous behavior. Anomalous behavior means different from other member. Behavior which is different from other member. First member have very high electronegativity. very high ionization enthalpy, very high, very small in size, and absence of d orbital. These 4 points are our anomalous property of element. So next topic is our diagonal relationship. Diagonal relationship. What is diagonal relationship and how elements show diagonal relationship? Which elements show diagonal relationship? So it is a part of our anomalous property. So in group 1, that is our group 1, group 2, group 3 means 13, right? Group 1, 2, 3 and 4 means 13 and 14, right? Members are lithium, sodium, potassium and so on. So we are going to write only two members here, only two members, first two members, lithium, sodium, beryllium, magnesium. In group 13 is right. So these members show diagonal relationship. That is the first member of group, and first member of group show anomalous behavior. So lithium shows different property than rest of member of that group. So lithium has properties similar to magnesium. Lithium shows property similar to magnesium. Similarly, aluminium. So these three members, these three first member of first group, second group and third group show anomalous behavior with diagonally anomalous behavior with or similar behavior with other group. Lithium shows behavior like magnesium, beryllium show aluminium and boron show silicon. Okay? So there is similarity between these two. Lithium, magnesium, beryllium, aluminium and boron shows property like silicon. And silicon is other group element. So this type of property is called diagonal relationship. So we are not going to discuss here how it's so chemical property, how chemical properties are similar or physical properties are similar. So we will discuss it in our next chapter, right? Now we will understand some periodic trend and chemical reactivity. So as we move down the group, metallic character increases. Metallic character increases as we move down the group. Why it happens? Because due to increase in size, Z, that is net effective force, decreases. Right? As we move down the group, metallic character will increases. So the next is our basic strength. As we move down the group, basic strength will increases. Why basic strength will increases? Because they due to atomic radii, they will lose electron easily. Reducing character increases. Remember that. How you can differentiate between reducing character and oxidizing character of any element? Reducing character means character to lose electron, property to lose electron easily, right? So as we move down the group, our metallic character increases. Due to increase in metallic character or due to increase in atomic radii, atom will lose, element will lose electron easily. So reducing character will also increases. Reducing character and oxidizing characters are Both are opposite things. So if reducing character increases, then definitely oxidizing character will decrease. So metallic property means our electropositivity. As we move down the group, metallic character increases means electropositivity increases. So you can say electropositivity increases, or you can say electronegativity will decrease. So these are 4 points on the basis of which we can classify, or we can found the trend of chemical reactivity. So if I ask a question that which one is more reactive, which one is more reactive than sodium or potassium, which one is more reactive and why? Or which one is more metallic, which one have more metallic property? Potassium will have more metallic property because potassium will lose electron easily, right? Thanks for today. I think that is our last topic of unit 3. So if you have any problem in any unit, any chapter, or if you have problem in any topic of this unit, just give me drop me a message on WhatsApp. So I will explain it in my next video. Thanks for today.